Hi there, in this short tutorial we'll try to explain these two applications related to chapter 6, which is Ohm's law. In this application, which is application number 1, we'll try to solve the equivalence and the calculation for current and voltage for two resistors connected in parallel. But before we start with application 1, let's take a small summary for this chapter. If we have two resistors connected in parallel, to find the equivalence of these two resistors, we must use this formula, which is 1 over R equivalent equals to 1 over R1 plus 1 over R2. We can use this shape, which is R equivalent equal R1 times R2 over R1 plus R2, which is more simplified form. If we have a series connection of resistors, we can just add them up depending on this formula, which is R equivalent equal R1 plus R2 plus R3, etc. Once we have to calculate the voltage, the current, or even though the resistance, we can use Ohm's law, which is U equal R times I. So these are all the formulas needed for these two applications. Let's start. In application number 1, we have these two resistors connected in parallel. The first one, which is 40 ohms, the second, which is 10 ohms. The current flowing given 1 amps. The first part, calculate the equivalence of these two resistors. Since they are connected in parallel, we need to use this formula or the simple form. Then we can substitute the values, which is 40 times 10 over 40 plus 10. These values are given in the figure. The answer will be 8 ohms. Then we can draw a new figure, as you can see here, which is one resistor instead of two resistors, and this resistor is connected to this battery. This is part A. In part B, they said that what is the voltage of this generator or this dry cell. To calculate the voltage U, we must use Ohm's law, which is U equal R times I. We substitute the calculated value for the resistance, which is R equivalent. Then 8 times 1 will be equal to 8 volts. And the current I is given 1 amps. In part number C, to calculate the currents passing through R1 and R2, this is the main figure given. The resistance for each resistor, as you can see, they are both given, and the voltage 8 volts, we just calculated this value. To find I1 and I2, we can use Ohm's law for that. So I1 will be equal to U over R1 and I2 will be equal to U over R2. Note that since this connection is parallel, then the voltage is the same. We can apply the law of uniqueness of voltage in a parallel circuit. So the voltage, which is 8, and the current, which is 40 for R1 and 10 for R2. The last answer will be 0.2 and 0.8. Now we can prove the law of addition of currents in this circuit. So the law of addition of currents states that I will be equal to I1 plus I2. We can substitute the value of I1 and I2 in this formula, and as you can see, 0.2 plus 0.8 will be equal to 1, which is proved. In application number 2, instead of having resistors in parallel, we have these resistors in series. The first question, calculate the equivalence. As we said, these resistors are connected in series, we can just add them up. So the resistance will be R1 plus R2, which is equal to 100 plus 200, and the last answer will be 300 ohms. In part B, they said that calculate the current sent by the generator. So to calculate the current I sent by this generator or by this dry cell or battery, we can use Ohm's law. Ohm's law states that U equal R times I, which is equal to the voltage is given 9 volts, and the resistance, we just calculated the value of the resistance, which is 300, and then we can find I equal U over R, which is 9 over 300, which is 0.03 amps. That's all for this application 1 and 2. Thank you.